Okay, guys, so let's go and let me share my screen. Let me share my screen. Do you see my screen? White screen? Do you see that? Okay, guys, so what we're going to be doing now is a very simple but interesting model, a financial model that is called net present value. Net present value. Okay, so the first thing you need to remember, guys, is let's define a little your economics and finance, right? So I assume you know this, but I will do a kind of very brief review. Okay, so we have two types of things. We have I, for me, is going to be the interest rate, and always is going to be compounding interest rate. And I, caps I, is going to be the interest rate, the interest. So this one here is normally in percentages, and this one here is going to be in dollars. Got it? So what happens is the following. Imagine that I want to compute my interest rate. Where is my mouse? What I want to compute is something that is, let's use something that is called a cash flow. Okay, a cash flow looks like this, guys. Imagine that I have $100 here, and then in the future, I will get 110. Got it? From here, my interest is going to be, let's call this equal C1, and let's call this equal to C0. So my interest is simply C0 minus C1. In my case, this is going to be 110 minus 100. So my interest is going to be 10. Got it? And now, what is my interest rate? My interest rate is going to be C1 minus C0 over C0. Basically, 110 minus 100 over 100. This is equal to 0.1. That is equal to 10%. Make sense? This is the first thing you need to remember, interest rates. Now, the second thing that you need to remember, guys, is that imagine, let's do one example. So you can help me with this stuff, okay? So let's do one example. Imagine that you have $100. And then we're gonna put this $100 only for 4 periods. And I want to know what is this value here. Got it? Before starting with $100, better start with letters, because from here we can better understand the things. So imagine that this is my C0. This is period 1, period 2, period 3, period 4, and period 5. Sorry, there is something wrong. Sorry, this is 0. Always today is 0, 1, 2, 3, and 4. Okay, so what I want from you guys is the following. If I deposit here C0, in period 1, my interest at period 1 is going to be the interest times C0. Assume that the interest for all the periods is I, or I%. So basically, this is going to be the interest at period 1, correct? So how much money I have at period 1? So C1 is going to be equal to C0 plus I C0. Common factor, C1 is going to be equal to C0, 1 plus I. Okay, so how much money I will have? What is going to be the interest at period 2? The interest at period 2 is going to be the interest rate times C1, but C1 is all this part here, C0, 1 plus I. So how much money I have at the end of the second period? At the end of the second period, I have my starting value, C0, 1 plus I, plus my interest, plus I times C0, 1 plus I. So at the end of the day, guys, C2 equals C0, 1 plus I, sorry, let me delete this part here. Common factor here is going to be 1 plus I. Correct? This 1 plus I, 1 plus I. Plus common factor between is going to be, it's going to be C0 1 plus I that multiplies 1 plus I. So basically C2 is going to be equal to C0 1 plus I to the power 2. Agree? And now if you generalize this, n periods, Cn is going to be simply equal to C0 1 plus I to the power n. Okay, so this is one of the equations that we're going to be using all the time. Got it? Now, in words, guys, this is called future value. Do you agree? Cn is future value. Well, we can call this, if this goes to the infinite, let's call this n periods, is going to be equal to the present value 1 plus I to the power n. Okay? And from here, the present value is going to be equal to the future value 1 plus I to the power n. Make sense? Okay? So, and from these formulas here, guys, we're going to start working something that is called the net present value. I will just do the very basics of net present value. Up to now, it's easy. Guys, do you get it? Yep. Okay. So let me save. Okay, so now let's go and understand what is the net present value. Imagine, guys, that we have the following cash flow. Imagine that you're going to invest $1,000 and that you just have two cash flows. One is going to be 900 and the other one is going to be 1,300, for example. Got it? So what we want to do, what we want to know is, do I do this project, yes or not? Is profitable? Is this project profitable, yes or not? So that's all what we want to ask, to answer. Got it? In order to answer that question, what we need to do, guys, is first I need to compute, well, I need to know what is my opportunity cost. So what is my opportunity cost? Some of you have an idea what is an opportunity cost? Ideas? What is an opportunity cost? Have you heard about opportunity cost? So it is basically, guys, is the interest rate that you're going to make if you don't do this project. Okay, so this is the interest rate that you can get if you don't do this project. Okay, that's it. So let's assume, guys, for a time being that my opportunity cost equals 10%, an easy number. Got it? So what is this 10%? So this 10% implies basically that if I don't invest in this project here, I can make 10% per month, per period. Got it? So let's take a look to what happens. Assume, guys, that this $1,000, forget about the upper part. Forget about the upper part. Just focus on this $1,000. If you say this $1,000 for 2 periods, so what we're doing is we're doing future value. So this implies that this $1,000 is going to grow at 1.1 for this period. So when you move this period, you multiply this times 1.1. And then to move to the second period, we need to multiply this times 1.1 squared. Correct? So let me check my calculator. So this is 1,000. Oh, that's easy. 1.1 squared. So this is 110. So the value of this one here is 1,210. Agree with me? So if you have your $1,000 and you have an opportunity to invest at 10% per year, let's say, so at the end of 2 years, you're going to have 1,210. Correct? Guys, make sense? Okay, so now let's just focus on the upper side of the equation, this part here. This $900 needs to be moved to the future. This is called compounding, guys. So in order to compound this value here, what you do is you multiply times the interest rate that it can make, 1.1. So if I multiply 900 times 1.1, I have here 990. Got it? So at the end of the year, at the end of the 2 years, I will have 990 for this 900 here and 1,300 at this period too. So in total, how much money I will have? I will have 0, 9, 12. I will have 2,290. Agree? So this is the money that I will make if I do the project. If I subtract this money from this money, so what I get is what? 0, 8, 0, 1. What is this 1,080? What is the meaning of this 1,080? Someone? This is basically what I get in the future minus what I need to invest in the future. So this one here, guys, is called the net future value. Okay, and the rule is simply if the net future value is larger than 0, you do the project. And it makes sense, right? Because what you produce with the project is much more than what you produce with the opportunity cost. So this project is worth. So you do this project. Got it? So this is the first concept, the net future value. In real life, guys, we don't use the net future value, but we use the net present value. Okay, so net present value implies what? Well, instead of going to the future, what I will do is I will move this in here. I will move this 1,300 here and here. And then everything is going to be in terms of present value, and then we simply compute the values. Okay, so the net present value is simply, I have invested $1,000, and I will receive $900 discounted by the interest rate, by the opportunity cost, and I will receive 1,300 discounted twice at the interest rate, at the opportunity cost. Now, this is equal to what? Okay, so you can help me, I will do this also. So I obtained 892.56. Someone can confirm this value?
Yeah.
Perfect. Okay, this one here is, as mentioned to you, is the net present value. If the net present value is larger than 0, basically do the project. Okay, so this is what we are going to be doing in MATLAB, the net present values. Now, there is another concept, guys, you need to know. It is called the internal rate of revenue. Just give me 1 second, guys. Sorry, guys. Okay, so the other one that is called the internal rate of revenue is called the internal rate of return, not revenue, internal rate of return. Also called as the internal rate of return, IRR. Got it? So what is the IRR, guys? Is simply, this is the average percentage return for the project. Got it? And basically, how do you compute this one here? Is a rate of return that makes the net present value equals here. It's simply that. So if we put this 0, my net present value equals 0, what is this number that makes this 0? It's going to be 900 divided by 1 plus internal rate of return plus 1,300 divided by 1 plus internal rate of return squared. Got it? So you have one unknown and one variable, one equation, one unknown. So you can solve this one here, and then you can get the internal rate of return. So the rule with the internal rate of return, guys, the decision rule, is that the internal rate of return is larger than the opportunity cost, then you do the project. Okay, so this is going to be our decision rule. Okay, so let's do this in MATLAB. Let's compute the numbers in using MATLAB now. So can you open your MATLAB, guys? I think I have so I can clean. Okay. So let's create our cash flow. Okay, so let's call this cash flow. I'm creating a variable, guys. Cash flow. Let's call it cash flow 1. And my cash flow 1 is going to be, MATLAB always understands matrices or vectors, okay? So I said this was going to be minus 1,000. The first one was 900, and the second one was 1,300, correct? And let me check just to be sure that we get the same numbers. 900, 1,000, yes. So let me save this one here. Oh, is here? Give me 1 second. Okay. Sorry, guys, I need to answer this stuff here. Just give me 1 second, guys. Okay, yeah, sorry for that. A lot of issues now. Okay, so let's do this in MATLAB. Okay, so what I will do is I will first, this is my cash flow. Everyone understands, so this is my simply the 1,000 negative 900 and 1,300. Okay, so what I can do now is I can compute basically the net present value. Okay, so we can do, for example, NPV NPV cash flow one. The MATLAB command, guys, is the PV var, is present value variable, PV, sorry, PV var. And then we simply enter. The first thing that we need to enter is a cash flow, is this one here. That I defined here. And then I need to enter my opportunity cost. Okay, so my opportunity cost, we said was going to be 0.1. And then we should get it. You see, my present value is 892.56. I think we compute the same number. 892.56. Got it? This is my net present value. And I can compute also the internal rate of return. Let's say internal rate of return cash flow 1. And the command is going to be internal rate of return. Okay, and internal rate of return of what? Simply my cash flow 1. I have it here. 0.68 is greater than 0.1, correct? And as soon as 0.68 is greater than 0.1, this project is better than the previous one. Make sense to you guys? Okay, so you do the following. Okay, so you do the following. So you have, this is cash flow 1. Give me 1 second. Sorry, guys. Today is a crazy, insane day. This is Monday, first day of the month. Okay, so what I want from you is, okay, you have cash flow 1, and I want you to create cash flow 2. You know, and let's say this is going to be $1,000 here, but perhaps it creates $1,000 here, and then after that they create $900 here. Okay, so what I want from you is the following. First question: in terms of the net present value, which one do you select? Okay, now in terms of the IRR, which one is better? Do they contradict? And then 4 is more MATLAB. What I want from you guys is I want you to create NPVs, all cash flows. And this is going to be basically NPV1 and NPV2. Then I want you to create internal rate of return all. That is going to be basically internal rate of return 1, internal rate of return 2. And then finally, I want you to put all. Basically, this is going to be a matrix that's going to be like that. NPV1, internal rate of return 1, NPV2, internal rate of return 2. Okay? 3 minutes to do this stuff.
Could you go back to the MATLAB code?
Yes, of course. Where is my here we go.
Thanks.
Yep. Okay. So what I need from you guys is this part here. Okay, one more minute, guys. Ready? Ready, guys? So it's 1,900. So let's do this. So I need to have my new cash flow. So I will simply do new cash flow is going to be 1,000 is the first cash flow, and what is the next one?
900.
900. Okay, so cash flow 2. So let's call this cash flow 2. And then we can do the cash flow 2. That is going to use cash flow 2. So this is my net present value. And then let's compute my internal rate of return of 2, cash flow 2. Do you agree? So if you just take a look to these two numbers, guys, which one is better in terms of the net present value? This one here or this one here? What is better for you? To get more money, to get less money? That's what this is telling you. Guys,
You get more money.
more money, do you agree? So according to the net present value, guys, cash flow 1 is better because the NPVs are better, larger. Now, in terms of the internal rate of return, also is the same. You want a higher internal rate of return because this means more money. Got it? So now the other part is more MATLAB working with MATLAB. So what I want from you is basically they don't contradict, okay? These two guys don't contradict. Now the net present value all, I want you to put this in a vector, and the internal rate of return, I want them to be in a single vector, and then I simply want to collect everything. Correct? So how do we do that? I will call it a net present value all. This is going to be equal to what? I don't want to type the values, I agree? So what I need to do is I need to create a vector here. And the vector elements are going to be 2. So where's my vector element number 1 is this one. And the second one is going to be this one here. Agree with me? So that's the way you join two elements, two vectors, two matrices, etc. So if you see this one here, oh, and this should be 1. Cash flow 1, right? Here you have your cash flows. Your net present values. We can do the same with internal rate of return all. It's going to be internal rate of return all, and this is going to be the first one and the second one. Got it? So we have created two vectors, 1 by 2, 1 by 2. Now, how can I put both vectors together? Well, we call this all. And all, guys, is simply, we can do, this is a 2 by 2. I can join the NPVs up, NPV all goes on top. And I want the next one below. So what I need to use here? I need to use semicolon. And then I simply join internal rate of return all. So this is what we were talking the other day. I'm sorry. It's not PPV all, it's NPV all. Yes, this is what I need. And here you go. Questions?
Why did we do that?
Oh, no, just for playing. Just to allow you to understand how you can join scalars. You see that? And then how do you join vectors? This is the way you can join vectors and create a new matrix. Do you see that? And you know, normally we do this stuff for presentation. So if you want to export this into Excel, for example, you want to present not one by one, you want to present everything in a block. And then you put the names here. It's going to be NPVs, it's going to be internal rate of return, project 1, project 2. And we're going to do naming conventions later. But at this point, basically, what I want from you is to learn how to create matrices with vectors or scalars. Make sense? Make sense, guys? Questions, guys? No questions? Okay, so let's do another topic and then we continue moving with this stuff. And this topic I will just run very quickly, okay? This is called amortizations. Or, yes, amortizations. Yeah. Imagine, guys, the following case. I will not do this, the mathematics. We're going to do this in Excel. Imagine, guys, that you want to have a loan for, let's say, $100,000. Okay, so let's assume that I want this loan for 3 years, 36 months. So we'll pay monthly the fee for this $100,000. Let's assume that my interest per year is 7% annually. Got it? And what I want to know now is the following. So I will receive $100,000. And then I will be paying for a long time. I will do payment, etc. for 36 months. And I will do a payment. Make sense to you? So this is going to be monthly payments for 36 months at 7% annual, and this is the principal. So the first thing we need to compute is, how do I compute the payment? Okay, we're going to do this just using MATLAB. But one of the things that you need to know, guys, is the following. It's time transformations, and I need you to understand how time transformation works. I will just create the formula for you. I will not develop the formula. So if you want to transform, guys, rates, imagine my interest rate 1 is going to be equal to 1 plus my interest rate 2 to the power of something here and something here. I will describe this in a minute, minus 1. So this is going to be my formula. And we're going to be using this in finance all the time. So this part here is the following. It's a ratio. Number of periods of I1 divided by number of periods of I2. The easy way to understand that is doing one example. So let's assume, guys, that I have an interest rate. I have an annual interest rate. Okay, so this is my interest rate for 1 year equals 10%. So my question for you is going to be, what is my interest rate for 1 month? What is my interest rate for, let's say, 4 months? What is my interest rate for 15 days? What is my interest rate for 2 years? Okay, and before moving forward, guys, there are a couple of conventions here. Conventions. There are a couple of conventions here, guys. One year equals 360 days. 1 month equals 30 days. Okay, so let's do one and you do the other ones. So if you have 1 year to 1 month, guys, okay, remember the formula is going to be 1 plus the rate that I know, 10%, 0.1, to the power of something minus 1. Okay, so what goes up, remember, is the period of this guy here versus the period of this one here. So here, if I have 1 month here, what I write down? I should write 12 months. Okay, and then you just calculate it and then give me these numbers. If you can do, please, all of them very quickly. Okay, guys. So what do you get here? Someone? So it is basically 1.1 to the power 1 over 12 minus 1. Okay, let me do this and then you verify if I'm right. 1.1 to the power 1 divided by 12 minus 1 times 100. So I will put this in percentages already. So I obtained here 0.797%. Someone to confirm?
Yeah.
Confirm. Got it? So I will do the other ones, just the formula. So this one should be equal to 1.01, 1.10 to the power of something minus 1. What power goes here? It's always, guys,
It's
this,
4.
yeah, 4, and the rate of the months of this one, 12, right?
Yes, correct.
Yeah.
Yeah, this one is going to be 1.1 to the power of something minus 1. Here comes the convention, so that's why we need to do the conventions. What goes up? 15,
15. Yeah.
and down?
360.
360. Perfect. And this one is going to be 1.1 to the power of 2 divided by 1 minus 1. And then you get the numbers, and then that's it. Got it? Okay, so let's do these numbers. I have loan 100, N36 interest rate, 7% annual. We need to transform this into monthly. Okay, so let's do that. So how do we do this in MATLAB? Okay, so let's do principal. Let's call this principal. Or you can call it as you want. Huh? I want this to be 100,000. Let's call this N equals 3. So we need to remember that this is months. Oh, anything that you want to write in MATLAB not to be computed, guys, you can write the percentage term. Percentage term implies MATLAB don't do this. It's just this is a note for me. And then we have an interest 7%. So I can write a note here. I say annual. Can you write, guys, I month? What is my interest per month? You need to do the formulas here. The monthly interest rate, guys, you need to write, you need to do the formula, okay? So remember the formula is this one here. Where's my formula? Is this one here. You have the 7%. Basically, you're in this case, right? It's going to be 1 plus 0.07 to the power 1 over 12 minus 1. That's going to be your monthly interest rate. Wait 1 minute. MATLAB receives matrices and formulas. You know, the formulas are very simple to do. And later we're going to optimize, etc. So this is going to be equal to what, guys? It's going to be 1 plus I to the power 1 over 12, right? Make sense to you guys? I is my 0.07, 1 over 12, because I need to transform this one here that is annual into monthly because my payments are monthly, minus 1. So let me check this number. Well, let's do format bank. Let me check. So let me change this to format long just to see the complete number. Yeah. So format, guys, format long is long. It basically provides you all the numbers. Okay. But normally banks don't use that. Banks round to the second decimal. So if you want to use the banker's notation, you simply put format bank. And this is what you can get. Format bank. If you do the again, looks like 0.01. Got it? But of course, mathematically internally, MATLAB internally keeps this number, no? This is a number it's gonna use for computations. Okay, now we have everything, guys. So now let's do another command that let's write here principal. Principal, remember, is the amount of money I owe at the beginning. I need to have a table. Oh, you know what? Let me explain first this part here. When you do a bank loan, guys, this one here, when you do a bank loan with these terms here, what you receive later is something that is called an schedule, payment schedule. Okay, and this happens. If you buy a car, if you buy a house, you buy whatever you want, always you're gonna have the following. So we have here the number or month if you want, 1, 2, 3, and then you have 36. Then you have your principal. Then you have your interests, the interest you're gonna pay in the period. Then you have the amortization. So basically how much of the capital you're gonna be paying this period. And then you have finally the payment. Got it? So the payment is going to be constant. So the payment is going to be X, X, X forever. And the principal, what happens is it will start big. No, it's large, and this is going to be decreasing in time up to the end in which you don't have almost anything. And the amortization, guys, is the amount of money you use to pay your principal. So let's do one example, okay? Just an example. Imagine this is, I don't know, $1,000. Imagine this was $10,000. Imagine that you pay in interest $100. So this implies that 900 are going to be interest because this minus this gives you the amortization. So how much do you owe to the next one? You owe $9,100. Do you agree? So my principal, my payment is also 1,000. Imagine, but now my interest is going to decrease because my interests are now based on this number. So now my interests, imagine, are 91. So I have 909 that goes to principal, etc. And this is the amortization table. So at the end of the day, guys, this number here must be equal to this number here because they need to net up to 0. Okay. But this is a table that simply tells you how much money do you owe at every point in time, how much money you are paying in interest rates, and how much money is your payments. And your payments are going to be constant for the sake of these examples. Got it? So this is what we try to build. We try to build a payment structure. Got it? I don't know if you're taking notes, guys, or if you are not, I can move faster. But if you are, I need to wait for a couple of minutes. Are you taking notes or I simply move?
I'm taking notes.
Okay,
Taking notes,
so yeah, please. Allow me then to get some water. 1 second. Okay, guys. So let's do this in MATLAB. Okay, so I will do the principal, my interest. So these are names, guys. Later we are going to learn how to create these ones by ourselves. Balance and payments. So these are the components that I mentioned to you. Remember, principal, interest, balance, and payments. The order must be kept, but the names can change. You can put here P, I, B, P if you want, whatever. Okay. So these are simply names. The MATLAB command is amortize. And what you need to enter is basically the monthly rate, this one. You need to enter the number of periods, whereas my number of periods is n. And then you need to enter, I only say n3. So there is a mistake here. 100,000 in 3 months is too much. So let me rephrase this one here, okay? Let me copy this. Let me copy this for 1 second. And let's rephrase n to be 36 months. Yep. Okay, so now I can copy this one here. So I have my interest rate per month is 0.01. I want this for 36 months. And the amount of my loan is called principal. Yeah, but I have a conflict of names here. Let me call my principal loan, okay? So guys, I'm changing names just not to confuse. Not to confuse with the name I'm gonna be using here. So I had principal. I had interest. I had amortization. And I have payment. And I call the command is amortize. My interest rate I month. Then I have my N, and then I have my loan. Do you agree? So these are the inputs that I need to put. It's my monthly interest rate, how many months, and what is the amount of the loan. Okay, guys. So if you if you click this one here, so we are going to create my amortization. Take a look. It is a lot of information. My principal. Okay. I have my interests. I have my amortization. And then I have my payment. Okay. So let me rephrase something here, guys. Sorry, I need to change this one here. The position of this one here, I need to change this one here to be here. Yeah, because amortization is let me check. Give me 1 second. I will tell you why I have discovered I have a mistake here. So the first one here is what? It's the principal. Yeah, this is my amortization. Okay, so the first one is my amortization. The second one, the last payment is the last one. Interest, I think, is the second one. Yes, interest is the second one. My principal and my payment. Yeah, so what I know that, guys, amortization is basically, amortization is the first one here. So how much money I'm paying from the principal is this one here. Okay, and then you see that this is going up. The second one is the interest. The interest is okay, it goes down. The amortization is what we call principal. So this is the third component. And the payment is the last one. So let me take a look to that one. I will just put this one here. So this is the correct way: amortization, interest, principal, and payment. So what you need to be only careful here, guys, is not the names, but the position is fixed. So the first one, according to the one that created this program, the one that created amortize, the first one refers to amortization. The second one refers to the interests paid, principal, and payment. Okay, and what is interesting, guys, you can see that everyone is if you can you give me the dimension of amortization, please? What is the size of the amortization? How many columns, how many rows? How do we know how many rows, columns, or whatever? What do we use?
Size.
Size, exactly. So what I can ask is, give me the size of amortization. Oh. Okay, this is what I want. So it is 1 row, 36 columns. Do you see that? And the same is going to be for interest, principal, but what about payment? Size of payment. It's a 1 by 1. So we have an issue because what I want, guys, is I want to build my, I have several issues. So this data here is in a raw format, do you agree? And I don't want the raw format. I want to put this in a column format. That's easy. You transpose, do you agree? So that's the easy part, you transpose. However, what happens is that this payment here is a single number, it's one number. But if I want to build my table, I need to repeat this n times, do you agree? So how do I repeat that? Well, this is a new command for you guys. Let's create payment all. Yeah, I can call it payment all or payment table. It's a name, okay? This is going to be equal to rep mat, okay? This is one of the commands we're going to be repeating all the time. Rep mat of what? Of payment. And then what? You need to have the same number of columns, the same number of rows as the other ones. So what I will do is size of amortization. What dimension, guys? 1 or 2? Take a look to the 1 or 2. Remember, size has 2 components. It has 1. If you put size 1, it will give you this one. And if you put 2, it will give you this one here. So that's the one that I want. So this is the number of columns. So I want payments to repeat 36 times and only 1 column. Okay, so if you want to see this one here, so let's take a look at that. You see? What I've done is I have made 30,077.89 to repeat only 36 times. Got it? Now, I need to change amortization is a 136. So what I want to do is if I do amortization transpose, what I'm doing is I'm simply transposing the data, right? Before it was like a row, now it's going to be like a column. Okay, so I don't need to do that. What I will do is I will create my payment table. Let's call it my payment table. Okay, and this payment table is going to be equal to what? How do I create that, guys? So remember here the names. I will put the names here. For the names. Here we go. These are variables that you have already created, okay? But I don't want them to be in this order. So what I want first is the principal. Then I want the interests. Then I want the amortization. And then I want the payment, but not this payment. I want this payment, the one that I have created now, the one that has the rep mat. Yep, sorry. I want this one here. Now, do you think this is going to work or not when we create our matrix? Payment table is what is going to be 36 times 1. But amortization is going to be 1 times 36, so it will not work, right? Principal also is going to be 1 times 36. And interest is going to be also 136. So what I need to do, guys, if I want to convert a 1 times 36 vector into a 36 times 1 vector.
Put apostrophe on it.
Yeah, we transpose, do you agree? So we simply transpose, transpose to principal. Sorry, I delete my L. transpose, and transpose. And then should run.
Professor, I have a question.
Yes, go ahead.
When you made the payment table, why did you put one at the end?
Oh, here.
Yeah, where's the one come from at the end?
Oh, yeah. This is rep math. What do you want to repeat? I want to repeat this payment. This is a single scala. The degree is $3,000. Okay, give me the dimensions of this new matrix. This one here gives me the number of rows, and this gives me the number of columns. You see? So basically, size is going to be 36,1. So 36 rows, 1 column.
All right, understood. Thank you.
Okay, perfect. Makes sense to you guys? So I start paying. And so imagine, oh, you know what? There is something missing here. I told you in this is missing. Can you add that, please? Add this to your table. So I want in the first column to be 1, 2, 3, 4, 5, 6, 7, etc.
Professor, sorry, could you just scroll back up to when you made the variables?
So you tell me. Up, continue.
Yeah. Sorry, I just missed that part.
Yeah, I'm going up, and up. Here.
Yeah,
Principal,
thank you.
loan. Yeah, loan. N.
Yeah, thank you.
Pleasure.
Okay, thanks.
Perfect. Okay. So what I want from you guys is to add 1 to 36 to the left of the table. So basically you can just work something here. It's a sequence, right? So sequences are easy to create. Okay. 30 seconds, guys. Okay, so how do you add something here, guys? Of course, I will add something here, right? That's all what I need to do. So it's a sequence that goes from 1 to 36. So what do you do?
limit space 136 transpose, or you can
Yeah,
use the size.
Yeah, that's right. You can do 0 to, yeah, let's do this more professional. Size of, if you want, PMT table. 1, right? Because this is a, and then I transpose this one here. Just to make it more efficient. Do you agree? I can write 0 to 36. Well, even we have this one here is much easier. This is n, right? But in any case, it's the same. Size of payment table 1. This gives me the 36, and then I'm transposing. Do you agree with me or not, guys? This is one way of doing this. This go, sorry, not 0, it's 1. 1 to 36 increasing by 1. If you want, you do this 1 increasing by 1. But remember, this is the default, so you don't need to do this. And here I go. Do you see this, guys? So how do you read this table? Okay, guys, can you please tell me how much you owe to the bank at the 22nd month? How much do you owe to the bank?
41,000.
Yeah, this is the amount of money you owe to the bank.
Yeah.
Agree with me? Okay,
Yes.
so now questions. How much are you paying in interests? How much are you paying in interest? So I will write my questions here. So question 1, how much interest you're going to pay? The second one, I want to compute. Tell me the interest paid until the 21st month. Okay, so we'll write somewhere. So tell me principal at 24th month. Using MATLAB, huh? I don't want you to look. Give me the number. So let's call this P24. This is going to be called my answer. This one, let's call it .int. Oh, no, sorry. This is .int. And let's call this guy, this one here, int21. So this is the name of my variables. Okay, 2 minutes, guys, to do this. Okay, guys, you tell me. Let's go to MATLAB. So the first question is how much I own in interest, right? So I need to just remember which column I'm talking about. I'm talking about the third column, correct? So I can call int tot is going to be equal to the sum of, what is this matrix called? Payment table. And what I need to, I need to use all the rows, third column. Agree with me or not, guys? So if someone is asking me, okay, give me the total of interest you're gonna pay during these 36 months, it's simply the sum, where the data comes from, payment table, where exactly, all rows, column number 3. So this is the amount of money I'm paying, guys, for this debt, for this loan here. You get the same number? Okay, do you get this number, guys? 10,803.96.
Yes.
Okay, perfect. So now the second question is what? The second question is, oh yes, I want to know the interest until period 21st. Okay, so this is a partial interest rates. So I call it int 21. And this is going to be what? It's going to be very similar to this one here, right, guys? The only thing that I need to change is what? This one. 1 to 21. Agree with me or not, guys? Or if you want, simply 2 dots 21. It's indifferent. Oh, no, it doesn't accept this version. So you need to explicit. Payment from 1 to 21. Third column. I am paying this amount of money. Do you get the same number, guys? 8,780.87.
Yeah.
Excellent. And so the last one. What is my principal at this position? It's not the sum. I just want to know what is my principal at this position, a specific position, 24. Of course, if I go to my table, I know that my principal is this one here, correct? But let's do MATLAB to do this. So this is my, I call it principal. I don't know what is the name. I call it P24. Okay, so it's going to be P24. P24 equals. Okay, we'll copy this part here. I want position 24, so the row is position 24. And then the column is number 1, 2, column 2. Make sense, guys? This is the amount of money, 35,612. 35,612. Do you agree? So you should be very comfortable now trying manipulating matrices, guys. Is, you know, how to call the names, what to do. You can do whatever you want with that. You can do this in small, you can do it in large. It's exactly the same. Guys, questions? So we can move into graphs now. It's clear? Okay. So let's start working on another thing. So let's say this one. Okay, guys. So what we want to do now is let's do very simple graphs, okay? And then let's do 2D graphs, subplots, multivariate graphs, etc. Okay, so let's do this. So let's assume, guys, that I want to draw. So let's do, for example, I want to draw y is going to be equal to sine of x, and x is going to be between 0 and 2 pi. Okay, and I want, so define x between 0 and x, and I want the first case x only 10 observations. So from 0 to 2 pi, only 10 observations. The second one, I want x, and then of course you compute y is going to be sine of x. X is going to be cosine of x, for example. Okay, and then x only 100 observations. And then the same, let's call y1, x1. That is the same, sine of x, cosine of x. Just create these variables first. Okay, x, y, x, y1, x1. Okay, so you need to first define x. So you need to define x between this interval, okay? So x is going to take the value of 0 to 2 pi, but I only 10 observations. And then another one with 100 observations. And then you create these variables, y and yx and y1, x1. 1 minute to do that, guys. You know how to do that already. You must know it.
Prof, you're on mute.
I was talking a lot for nothing. Okay, guys. So what I was telling to you is that please start learning the language because we're going to be building up more and more. Okay, so at this point, everything is separated, but soon it's going to be all together. So and I hope you can be, once you understand the language, the words, you're going to put them all together and build beautiful stuff. Okay, so let's define x, and I want between 0 and 2 pi, but only 10 observations. What do I use? What do I use, guys?
Linspace.
Aha.
Space.
Exactly. I use linspace because the beauty about linspace is that allows me to do exactly 2 times pi, exactly the number of observations. Do you agree? Make sense? So this is my x. Well, if you want to see the x, it's only 10 values. Got it? And now I can create my y. My y is going to be sine of x. I will not print this one here. And my z is going to be cosine of x. Agree? Now let's create a new variable. Let's create x again, but now x is going to be, where's x? It's going to be, instead of 10, it's going to be 100. And then I create my new variables, y1 and c1. And then I have everything to just create a couple of graphs. Okay, guys, so I'm ready to do some plots. Okay, so let's do the very simple plot. Okay, the MATLAB command is plot. And what I want to plot is x, always the x, so the horizontal line goes first, and y. Okay, so take a look to what happens. What? Oh, yeah, sorry. I need to go back to my x, to my original x. Otherwise, I cannot use my y. So you see can you draw this one here? Can everyone be with me? Because I want everyone to be following me on the graph side of the equation. Okay, do you have this graph here? Looks very ugly, do you agree? Looks like lines. So why is that? Because we are using only, what, 10 points. So the way to solve that is simply increase the number of points. Got it? Now, a couple of things here, guys. If I want to create an additional graph, okay, pay attention to me. If you want to create an additional graph, what you need to do is you need to type figure. What figure does is creates an empty space for you to graph again. Got it? And then I will do here is I will plot my X and my Z. So you have now two graphs, the sine function and the cosine function. Got it? Now, there are some instances in which you want to put them together. So I want the sine here at the same time the cosine. Okay, so in MATLAB, what we do is we tell MATLAB hold on. And so this is telling MATLAB, please keep the one that you have active here. This is going to be my active window. And please draw in the same window, in the same figure, the following. And here you go. You see that? So things to remember. Figure creates a new empty figure. Hold on puts more graphs in the same graph. And then what you want to continue graphing without this restriction is hold off. And then you can continue graphing in different figures. Make sense? Okay, now can you please create X, the new X with 100 observations, and then make the graph of Y, X, Y1, XC2. Okay? So first you need to define your new X. Not this one. This one here. Okay, do you have the graphs? So let me close. Well, let's create new figures, okay? So we can just practice. And then what I want to do is I want to plot X with Y1. So this is my X with Y1. And you can compare this one with this one here, guys. Take a look. See the sine function? Looks nice, right? Versus this one here. And everything is just because the number of observations increase. Okay, so you're doing linear interpolation that is much thinner, much thinner, and then your graph looks much better. Everyone is with me? Okay, so we can do another figure. and I want to plot X with Z1. Can you do the graph of both of them together, please? So I will delete the ones that I don't need. Don't need you, don't need you. So what I need now is these two things to be together. Okay, so I can do the hold on. Sorry, I need to put active first, the one that I want to work with. I want this to be active. Remember that I want this to be active, guys. And then what I can do is my hold on. Then I do plot my Z1. And then I need to do my hold off just to remove this one here. So we should get something like this. Ready, guys? So now what is interesting, guys, if you want to save this one here, if you want to save this one because this is going to go into your papers, your thesis, etc., what you do is you go File, Save As, and the format that we recommend, guys, is the following. Where's mine? Yeah, the format that we recommend for Word or for LaTeX is the EPS one. Okay, it's very good for text. Now, if you want to change this figure in time, so imagine you want to save this figure and then let MATLAB call this figure again and modify this later, you need to save it as .fig. Do you follow me, right? So if you want to modify this figure in time, you need to save it as .fig. And if you want to save this just as an image, the EPS is the best one. Got it, guys? And you do this in the same graph, in the same figure. You just go here. And you can make edits on the graphs. You can add a lot of things here. We're going to do a couple of them here. Make sense? Okay, now there is a bunch of things that you need to learn from the plot menu, guys. You know, just to show you some, take a look to the menu that you have with the plot command. You can do dots instead of lines. You can do dots. You can do circles. You can do X marks. You can do solids. These are the colors that you want, etc. Got it? So what I can do, for example, just to show you this one here. Let's do a figure. Okay, I want to plot. Yeah, I can do a single plot. I can do X, Y1, and I want X with Z1. I want Z1 to be a cross. And this cross, I want to be green, for example. Okay, so you can do this in pairs, guys. You do X with Y1, it's going to create the same graph. X with Z1 is going to create the same graph, another graph in the same figure. And then the last one I want to be a cross. So instead of dots or lines, it's going to be a cross and it's going to be green. So why it didn't accept? So X. Oh, I don't have the cross. Oh, yeah, I have the cross. and green. Okay, so what? Let me check first if I do this. Next one. Okay, so why is not accepting the other one? Give me 1 second. And not this one. So let me close this one. I don't need this one. I don't need this one. Yeah, here we have the crosses, but I want this to be green. So why is not accepting that? Give me 1 second. It's okay. So this should be G. Yeah, let me see, guys, why it's not accepting this one here. Okay, let me check if I do this one. Oh, it's only accepting one now. Interesting. Yeah, let me check, guys, for next time why. Normally it should have accepted, but this is a new version that I have here, so I need to be exploring more. What makes sense to you? Okay, can you do the following plots? Just for fun. Do the following plots, guys. I want you to plot independent graphs, okay? In new figures. In new figures. Can you please plot y1 versus z1 and see what happens? Do you remember sine of y, sine of x squared plus cosine of x squared was equal to 1, correct? Remember that? Just plot this one here. Oh, the other one is very interesting. Can you plot, remember that, so let me answer again, guys. Remember that 2 sine of x cosine of x is equal to sine of 2x. So plot this one here. And plot this one together with sine of x. Okay, this is important, guys, for seasonality. Okay. So yes. So plot, just make this graph. The plot should be based on this one here. Okay. Sorry. Okay, 1 minute. I will want you to play with these things here, guys. Ready? So let's take a look to what happens. I can close this one here. Delete this. So I want to plot basically y1 with x1. So what do we get? Oh no, it's not x1, z1. Have you heard about the unit circle, guys? That the ones that are in economics and do econometrics, we always talk about the unit circle. Or when we do dynamics. So we want, if we want the stability of the coefficient estimates, these coefficient estimates need to fall outside the unit root circle. Okay, forget about that, but just remember that this is the famous unit root circle, guys. It's one everywhere. Okay, so the second one was we want to plot x versus this is sine of x, so I want this square plus this one here is cosine square. Do you agree? So this is sine square plus cosine square. Of course, we need to do dot is element by element. Here you go. Do you remember? Sine square, cosine square. Make sense to you guys? Okay, so now let's do the other plot. We said that plot of 2 times sine of x times cosine. So I want to do this first figure. And I want to plot this one here, correct? Yeah. Again, it's element by element. So it's 2 times this one here. Yeah, you see that? Now you don't see what's going on here, but basically, guys, the amplitude has decreased by half. Okay, so take a look. Let's plot on top of this the cosine, the sine function. So let's do a hold on. Yeah, I think it's much better to hold on, and let's plot x with y1 that is the function sine. You see that, guys? So basically what we're doing is that is the amplitude of the sine function simply decrease it by 2. If you want to decrease it by 3, you decrease by 3. And this is something that we use a lot, guys, in seasonalities, for example. You know, if we have a yearly seasonality, you know, perhaps we are interested about this one here. So this is the summer. This part here is the summer of every year. This part here is the winter. And this happens for products, ice creams, for example. You know, you have this seasonality is very, very marked up or down. Also in cough, cold remedies. This is winter. A lot of products are sold during winter. During summer, almost disappears. And then this is the way you do it. You want to make the amplitude thinner, sorry, wider, thinner, whatever you want. Make sense? Now I will use this one here to add additional things, guys. You can also label that, and you use X label, and then we can put whatever name. So this was what? X. We can do Y label. Let's call this Y sine. Is a name. Okay, perhaps we can do a title. What do you want to call it? I know. Multiple sine functions. Just names. Okay, if you take a look to your graph now, multiple sine functions, your x, your sine, etc. Make sense to you, guys?
Hey, Professor, one quick question.
Yep.
Is it the amplitude or the frequency that is shown on the plot?
In this one here is a frequency.
Okay, okay.
Is a frequency. Because you're making the graph frequently, more frequently. The blue one is more happens frequently than the red one. You're completely right. I'm keeping the amplitude at 2 pi at this point in my graph. Okay. So what you can do also, guys, is now while we have that. Yeah, one thing that is interesting is let me check. Yeah, can we? Yeah, we have figure 2. So in figure 2, guys, I will simply add. Let me hold off for a minute. Okay, and I want to simply plot my XY. And I want to plot my XCY at the same time. And just hold off. Okay, so my graph is this one here, and I want to tell you. I just need you. Okay, so imagine, guys, that I want to add a text here. I want this to be sine of x. I want that the sine of x appearing here. Okay, so what I can do there is simply I can write text, and I need to give the coordinates. So what is a coordinate here? It's a kind of a pane. I show you a different way. So more or less at 2.5 and 0.7, perhaps. You see 2.5 is going to be up, and 0.7 is going to be here, more or less to appear here. So what I will do is 2.5 and 0.7, and I want to write the function. What function was that? I think it was sine of x. Okay. So what happens here now in the figure is this one here. You see, appear wherever I want. The issue is that it is a pain, do you agree, in terms of just giving the exact dimension here. It can take time. So instead of that, guys, what we can do is just type G text. G text, what I want to do is cosine, this is the name, cosine of x. I want to put this in my figure somewhere, okay, somewhere. Now take a look, appears the cross, and then you simply stay where you want this to appear. So I want this to appear here. Click, and that's it. Got it? When we do the programs, guys, I will show you specific ways of doing that. MATLAB is going to do this automatic for you. But if you have a graph and you want to put legends, graphs, etc., you can use this part here. Okay, guys, questions? What I want from you guys, let me check if we have the table. Remember, we created a table, our amortization table. Do you remember that? Payment table. So we have, here you see, guys, we have principal, we have interest, we have all these guys here. Principal, interest, amortization, and payments. Okay? So what I want from you is the following. Okay, using the amortization example. Graph in a single figure. The balance. The cumulative sum. So this is a MATLAB command, cum sum of principal. All in the same graph. The cumulative sum of the interests. I have balance, principal, interests. Yeah. Okay, guys, do this. It's just simply plots, right? And that's all we need, plots. Okay, so what do we have? So we have plot balance, but there we have that. Perhaps we can call it B, black. And then I want to do a hold on, right? Because I will draw more graphs on that. Let me delete this graph. I don't need this. Oh, I don't have the balance. Come on. Seriously, where is that? Principal interest. Oh, I have principal interest. So it is not balance, it's principal then. Okay, so let me check. Yes, this is my principal. Do you agree? So my principal starts at $100,000 and then disappears, and 36 months disappears to zero. Got it? Make sense? So now let's continue. I'm in a hold on. So I will plot the cumulative sum of how do we call it? Amortization, I think. Amortization. I don't remember the name. Let's check. Amortization, yes. And then let's call this perhaps what color? Ah, here we can do something like that. Okay, need you. So let's take a look at what happens. Amortization. Oh, I need another. Yes, I need another parenthesis.
After amortization.
Oh, yes. It's my cumulative sum is of this one here. Yes. Cumulative sum. And then let's see. Plot. Yeah. Yes, of course. Why not?
There's an extra one at the end.
This one. No, should be countdown. Yes, no, that should be it. Here we go. So this is basically my amortization going on there. And then the last one is going to be interest, right? Interest. Oh, well, we can call this different. We can call this green, perhaps. Where is my green? I don't believe this is my green. I don't believe this is. I need to check my variables, guys. So I'm trying to. Okay, so I want to check this one for 1 second. So I want to print this one here. This one is my principal. That's okay. I want to print, oh, amortization is this one here. And my interest rates are these ones here. Okay, so let me check if this is true. Yeah, so my principal goes up, my interest accumulative go like that. So that's okay. So this is basically my graph, guys. So my principal decreases, in time. The principal payment increases in time, and the interest rates at the beginning are high, and then they simply disappear. What we can do is let's do perhaps a legend. This is something that you can add, guys. So let's say principal. That the second one was what? Amortization. And then the last one was interest, right? And this is cumulative amortization. And this is cumulative interests. . Okay, so let's take a look to our graph. So this is a new command, this is legend. And here you go. So we can make this big. So my principal, my cumulative amortization, I can change the, and green, you don't see this is green, cumulative interests. Make sense, guys? Do you get the graph? Everyone is with me? Yep. Okay, so let's do some more graphs related now to financial stock markets, okay? And then they are interesting because at the end we're going to join them together in beautiful stuff. Can you take a look if you have this one here in your version is a simulated stock.map. Can you verify if you have this one here? So just do load of this one here. Do you have it? Perfect. So this is what you have here, guys. Is the one that I want is a TT. Oh, we have these ones here, TTW, and then they have a lot of observation. It's a 1,000 times 5. So I don't wanna use that. So let's do a range. So this is just a name. It's a variable name. So do my range equal 1 to 25. Just the first 25 we're gonna draw. Okay. And what I will do is I will do high-low. So this is a MATLAB command. It's the high and the low. I will explain it to you. TMW, the variable that I have is TMW, yes or not? Yes, TMW, just of range, all columns. And then perhaps I will do this red. And I want to close this graph. Okay, so let's take a look to how this works. So this guys is the following. Do you have this graph? Okay, first make the graph, guys. And I will do the title just to remember. Title is going to be high, low, open, close, open, close. Okay, so my graph goes here. So just take one, okay? The left is the open. You see that there are two, this one is better. You see that there are two horizontal lines. The one in the left is the open. The one in the right is the close. The height is the high and the low. Do you see that? So this is per day. So this day, for example, the market went down. Do you agree? It started high, went down. But it was periods in time in which there was a high and there was a low. Make sense to you guys? Do you understand this graph? Okay. Another graph that we're going to use a lot, guys, is something that is called the Bollinger Band. Okay. So for that, let's create Bollinger Bands is simply number of standard deviations above from the moving averages. Okay. So let's do, can you do this? Let's do middle, up, and low. So these are names only, remember that? And my Bollinger, this is the command Bollinger TMW. So what it does is simply computes the Bollinger, computes the moving averages. Normally the default is 10. So you look for 10 observations in the past, compute the average. Then the next one, the next 10, the next 10, the next 10. And you are forgetting about the previous ones. Okay, and then once we have this one here, we need to create basically, let me talk about, let's do close Bollinger. Yeah, let's do, I need to do some references here. Close Bolling. So this is a name, guys. And what I will do is, I will do mid, close. I will do up, close, and I will do low, close. Okay, so what I'm doing here, guys, is I need to give you more insights about how this works. But the thing is that what I've done is I have created a mid, up, and low in the Bollinger, but these are tables. Got it? And from here, what I need to close, I need to get is from the mid, I need to get a close. From the up, I need to get a close. And from the low, I need to get a close. Because you're going to see it's a bunch of data there. And then what I will do is I will plot. Yeah, mid time and close Bollinger. Come on, you know. Mid close, up close, low close. So Y is not low close. Y is not accepting this one here. 1 second. Yeah, we have everything. So Y is complaining. Okay, so I have middle, upper, mid, up, and low. The Bollinger is good. Okay, then I have should have my plot. So why is not taking this one? Mid time. Want to be sure. I need to check, guys, what is going on here. Line 29. Yeah, the name is correct. Yeah, guys, let me check what's going on here, okay? But I don't want to spend more time because I have the time correct, I have the close Bolling correct. So what is going on here? Okay, we come back to this later. It's interesting that it doesn't work, but in any case, well, we can do also candles. No, this is much easier. This candle, TMW is my name. Let's say that the last 20 observations, n minus 20, for example, to n, everything. And I will call this blue. Okay, so what I'm doing here is candles, guys. TNW, this is n, the last observation minus 20, up to the last observation. And then we should get this type of things. So this is something that you always see if you go to, for example, Interactive Brokers or you go to Robinhood. This is what you see all the time. Got it? When it's blue, okay, or dark, sometimes it's red. When it's blue or dark, guys, this is good news. So the market was up. So this means the following. Take a look. The lower one is the end of beginning of the day, end of the day. We have the maximum and the minimum. Now, what happens when we have a white one? The white one means bad news. The day was bad. So this means this is the opening, this is the close, this is the low, and this is the high. Make sense to you guys? Okay, just remember how to read this stuff. We're gonna use that later in time. Okay, one last thing, guys. Let's do again. What was my x was equal to linspace. Yeah, let's go back to this one here. Okay, let's go back to your y equals sine of x. I don't know if we have modified this one. Let's go to your c equals cosine of x. I don't know, let's go to a equals sine of x times cosine of x. So let's call this 2 times. And this should be element by element. So let's create everything. Oh, no, I didn't want to do that. Semicolon. And then let's do b equals sine of x. Oh, sorry, this is y already, what I'm doing. This is y squared plus c squared. And this is y1, and this should be c1. Correct, guys? So what I've done is I've recreated all the variables. Now, what I want to do is I want to create a graph that looks like this. I have 1, 2, 3, and 4. I want here to put the sine of x, the cosine of x, 2 times sine, cosine, and sine squared plus cosine squared. So I want to do this one here. This is what is called in MATLAB a subplot. Okay, now subplot, guys, is the same. Subplot, how many rows, how many columns, and then the position. Okay, this is the way it works. So let's create this subplot. So it's gonna be, it's very simple. It's going to be subplot. I want is a 2 by 2, and in the first position. So what I'm saying is this is going to be the first position. Let's plot there x and y. Okay, so if you see before when we draw the subplot, it created an empty space for the first position. 2, 2, it's going to have 2, 2, and the first position empty. What I will do there is I simply plot x and y. Where's my graph? Oh, what is it doing? Here we go. Do you see? So now let's go to the second position. So it's going to be 1, 1, 2. And then what it has created is an empty space in position 2. And then I want here to plot with Z. You can take a look. Here we go. Make sense? And then we continue doing that. So the other one is going to be a subplot 3. So we go 1, 2, 3. It is horizontally, then down. I want this to be, what was that? B. X with B. It is here. And then finally, what I want to do is subplot 4. I want to, oh, well, I mixed up, guys. This should have been, it doesn't matter. I just want to show you the graphs. So we have everything. You see that? You understand how this works? So subplot, you need to define first a matrix, how many rows and columns you want to have. And then when you start naming, calling them, it's going to be 1, 2, 3, 4, 5, 6, etc. It goes this way, this way. Make sense to you guys? Questions? I think we are okay. So guys, we stop here for today. Next class, we finish it. The first 5 minutes, we're going to finish the graphs, and then we're going to go into more into more finance, and we're gonna put the things together more. Okay, no, we're gonna use more economics for the next couple of classes, but finance is going to come naturally. Okay, as soon as I have the videos, guys, I will share this with you so you have time to review them, and we're gonna be practicing more. Okay. Okay, guys. So see you in a couple of days. You have already the assignment. It's not going to be the assignment for today. It's gonna, you can be doing some of that, but you're gonna be ready to finish everything by Wednesday. Got it? You don't need to
Alright.
solve anything by Wednesday. You need to start working. This is gonna be due on next week, so you have time.
All right.
Okay.
All right.
Okay, guys. So have a good night. Take care.
Thank you.
See you guys.
All
Take
right.
care.
Thank you.
Prof, just a moment.
Yeah. I'm here.
Oh, yeah.
Oh, let me stop recording. Yeah.